Hello, my name is Kapil, and today I'm going to be talking about mixed initiative orchestration technologies. So, training undergraduates in conducting authentic, independent research provides them many benefits, including learning regulation skills and planning skills to actually conduct the research itself, but also learning how to deal and work on complex, ill-structured problems that they'll naturally encounter in the real world. Today, I will focus on the Agile Research Studio model of training undergraduates. It's a socio-technical system that supports research communities of practice by integrating multiple processes, including planning, progressing, and reflecting, social structures, including dedicated team or special interest group meetings, and also broader studio meetings across the entire community to support its community members. ARS allows a single faculty member to mentor 20 or more students in conducting independent self-directed research. However, there is still existing challenges in ARS that arise when supporting or orchestrating support for students' help needs. From prior need finding, we found that two core issues makes orchestrating support challenging in ARS. The first deals with the need to monitor the status of the community and understand what each student's diverse needs are week to week. While ARS follows a distributed apprenticeship model where PhD students lead a small group, it's often still necessary for a faculty member to come in and help address needs that students may have, since the PhD students are actually still being trained on how to become an effective mentor and also learning how to do the research. And so this requires that mentors must be aware of what the students' needs are. However, maintaining all this information for one mentor is very challenging cognitively, because there are so many difficult and different projects that are occurring in the studio. The second issue that we found is that coordinating help requests when they're identified is very difficult when you have to think about both how you're going to coordinate across students in the community and also the scarce one-on-one mentoring resources that a faculty has, such as office hours or ad hoc meetings. And so what would happen now is that individual resources can sometimes become overburdened or needs go unfulfilled because faculty resources have been used up for this week. This coordination process thus requires you to think about and reason about trade-offs of addressing a need now versus later if you have limited faculty mentoring resources, but still ensuring that your needs get addressed so that students are making progress on their research. So prior work for promoting awareness of project status is generally limited in how they address and detect diverse needs. So for example, in work platforms such as Asana, Trello, and Jira, we can provide a team or a community awareness on what the status of a project is, the progress on individual tasks, and the overall productivity of the group. There's also been further research in supporting teacher awareness in learning communities that provide dashboards to see what students who are working on similar problems are at in their current process. However, these approaches are all limited because they don't help a mentor to understand what the diverse needs are that occur when students are working on different projects. Moreover, these tools are really focused on what the outcomes are. So a student doesn't get something done or a task doesn't get fulfilled in a work platform, rather than thinking about what things may come up as you're doing the work itself. So in a software project, for example, it's not about whether a feature was built or not, but potentially a challenging bug that a developer encountered while trying to build a software feature that actually prevented them from moving forward. So on the other hand, for coordinating support, there's been a lot of work done in work organizations to build computational supports for finding answers that you need. But these are focused on a single person finding the answer that they need and not thinking about the distributed fulfillment of needs that you have in a research community like ARS. Other work in distributed task routing, including Jabberwocky and Hit or Wait, have focused on how you can direct tasks to a person based on their expertise, or how you can have a person best contribute to a group's collective needs or collective goals. But there's still little work about how you would actually try to fulfill all the needs in a community, or how best you would fulfill those needs with existing limited resources, and thinking about how to coordinate with both of those. So our conceptual approach to solving these two problems. In order to reduce the burden of monitoring the status of community members, what we propose to do is encode the existing strategies that mentors have for identifying and addressing their diverse needs into a machine executable format that can then be automatically monitored for and triggered. Then once these needs are created, or once these issues are created, I should say, we then propose a system that allows mentors to formulate strategies for addressing needs across a community as a whole and reasoning about their impact on the scarce resources of the community. And so to address these challenges, we propose mixed initiative orchestration technologies for supporting research communities. We first start with orchestration scripts, which are structured ways for mentors to represent their existing orchestration strategies in machine executable ways. Each script encodes a goal that mentors have and want to promote in the community, a condition that determines when the script should trigger based on the existing data in the studio, such as sprint planning data or help-seeking graphs, the actionable feedback to provide when the condition is met, which includes the feedback itself, so for example, seeking help from a certain person, and who it's sent to. So you send to the person itself, or maybe you send to peers to get their help too. And then an escalation strategy for when progress on a need is not made. These scripts allow for these issues to be automatically created when the condition arises, which then allows us to build further computational support that help reason about how best to address those needs. One of these computational supports that we propose is the resource-aware orchestration engine, which helps mentors strategize about how to fulfill needs. And so the way it does this is, for example, if a student in ARS might have a less critical need at the beginning of the week, so for example, need 2 here, it would actually suggest that you defer this need because you don't actually need to fulfill it right away. But then later on, you might see that a new need arises, so need 4, for example, that needs to be immediately addressed. And so you'd expedite that need and fulfill it using, for example, an ad hoc meeting if there's nothing else in place that would solve it. And unlike orchestration scripts that are automatically triggered, the resource-aware engine doesn't automatically trigger these interventions. So what it does instead is it presents strategies and allows mentors to tweak the strategies and see what the impact of that tweak might be on addressing the current needs, addressing potential future needs, and the burden that the community must take in order to address them. This is due to potential tacit knowledge that a mentor may have about the community, such as whether a resource is actually available or not, and might not be represented in the system. And given that it might not be represented in the system, a fully automated approach would only make suboptimal decisions since it doesn't know the full state of the world. And that's why we propose a mixed initiative solution. So to start with orchestration scripts, what we have here is a simple interface for creating orchestration scripts on studio data. Currently, the studio data that is supported are details about the sprint logs, including the number of points available, the number of points that people have committed, and the number of hours that people have spent working on their sprint. So what happens is, as these scripts are created, the data itself is replaced by whatever the current data is in the sprint, and then evaluate to see whether the condition will arise. So for example, we can use this to write a script where we want to prevent undergrads from overworking. And what it does is we want to check whether or not an undergrad has spent more than 120% of their available points in a week, so usually 8 to 10 hours, working on their research. And if that happens, we want them to reflect and think about what happened and why they went over points, and then how they can potentially do better next round. And in this case, we only wanted to run an undergrad project, so that's what we have selected here. So once these issues are created, we then must be able to monitor changes in the data and then actually start to execute these orchestration scripts when conditions trigger. So the current version of our resource-aware engine allows monitoring to occur on the sprint logs here, and then it identifies when a potential trigger has been, or when a potential condition has been triggered, and delivers actionable feedback via Slack. Currently, there's not work that explores how exactly the coordination and the progression update of a need occurs, but that would be future work. So for next steps, what we have for next steps on orchestration scripts are to start pulling data from other resources so that we can actually start getting a fuller picture of the community and start building much more complex conditions based on many inputs of the studio. So specifically, we would look to see what different peer research matchings have occurred and how people have helped each other there, and also just generally other help-seeking graphs that we get from end-of-quarter assessments where each studio member says who they helped during the studio and who helped them. This might not necessarily be doing peer research, it could be outside of it as well. For the resource-aware engine, the next part would be to allow a mentor to strategize about how current needs in the community can be addressed. And so we must design an interface for showing what happens if you would run a certain strategy and what that burden would put, or what burden that would create for each individual resource that we have. And then additionally, we want to be able to start actually detecting progress on issues and determining if escalation should occur or not. And finally, we want to evaluate how these systems actually affect an ARS community. And so we would study these both in the URG process, which is a very structured process that many undergrads go through in their first or second quarter of DTR, and then more broadly, just orchestration in general, but with different needs surfacing week to week. And we would do these all in this context of the DTR program at Northwestern. And so the core takeaways for this quarter is that orchestration in an ARS community, or in a research community in general, even with good existing processes, is still hard, and it proposes two key challenges. The first is the need to monitor for diverse need week to week, and the second is coordinating the support without overburdening any single student. And the second, we've started to design some mixed initiative orchestration technologies that help to address some of these issues. So in order to monitor for them, we create orchestration scripts that encode existing strategies and mentors for identifying and addressing diverse needs that they might have into a way that can be machine executable. We can then take what the issues that these orchestration scripts create by executing and help mentors formulate strategies for addressing them using the resource-aware engine, where the engine helps to reason about the impact of executing a strategy on the community's scarce resources, and also how effective a strategy would be at actually addressing all the needs. Finally, by further studying these technologies and actually evaluating them, we hypothesize that they will significantly increase the efficacy and scale at which a single mentor is able to address the needs that arise with students conducting self-directed research, which would then allow students to increase their productivity while ensuring that no individual student in the community is overburdened.